I am now ready to put the 16th balsa sheeting on the sponsons. Got all the foam cut for it, fitted in there. Thought I'd do an update of what I've done to this point. The center section, the plate, tunnel plate, had a bit of a bow to it. So I've wet it 3 times before I started putting this together. And with it pinned down, I've let it dry. So I got most of it out of it, mostly flat, but I was getting a little bit of curl. And I was not getting my 2 degrees on the inside of the sponsons. So what I've done is, with these blocks right here, I cut and sanded them to fit to where, with it pinned down, I got my 2 degrees. So the center tunnel was mostly flat, but these pieces that stick through here had a little bit of a curl. So I cut, sanded, and fit these blocks here to wedge that out to where I have nice straight lines down through the top and the bottom of both of these stringers. Once I had those wedges in place, I took it off the board. You can see it right here hanging out on this end. On the bottom side of the tunnel, I put 2 layers of 2-ounce fiberglass cloth. When that took a set, I pinned it back down on the board to cure. I wanted to make sure that I didn't have any twist in the tunnel plate. So that is fired already, and I can take these blocks out now at this point. So now I have a flat tunnel plate. I have it reinforced on the bottom side, so that will be under tension, because it's as the weight of the center tub here, motor, all the electronics, the battery in there, as it's hitting the waves and it's contacting these sponsons, the bottom of the tunnel with that fiberglass layer is under tension. So I'm going to keep it pinned down on the board to the point where I actually glue the sheeting on the sponsons. Thought I'd also show this, how I fit these foam blocks. So I cut the blocks to length with a razor saw, the blocks of foam from this. Once I had the blocks cut to length, then I cut slots, so 45-degree slots to clear this, and then just straight slots here to clear these tabs right here. Then I put them in place and took a magic marker, sharp magic marker, and I marked the outline of these formers on both sides. From there, I took a sharp knife and took each piece out after I marked them, and then I cut them to fit. So I fit all these pieces to where it'll be snug, but it'll just clear when I put my top the bottom sheeting and the non-trip sheeting on. Figuring I'm going to have to put the foam pieces, well, first I'll cut the sheeting to fit, and then I'll have to put the foam pieces in because they're engaged like this on all these tabs. So I'll have to actually glue the non-trip surface on, sand that flush to these formers, glue the bottom sheeting on, the ride pads on the bottom of the sponson, and then lastly, and then sand that to the non-trip sheeting, and then sand the non-trip sheeting down, put the top sheeting on, sand that top sheeting to the non-trip sheeting. So that's the process of sheeting the sponsons with the foam in place. Prior to fiberglass in the bottom of the transom plate, I also have everything glued together. What I did for that was this motor mount plate, this one, the servo mount, I sealed the bottom side first, so I won't be able to access it. And I sealed the bottom side of this front plate, and in the bottom of the center section, I sealed that with thinned epoxy. Then I glued that together before I did the fiberglass on the bottom, like I said. So said I would show these pieces, take it apart and glue this all together. So looking in here, there is my cutout, and that these two holes here and here, that would fit a mini servo. And then I made this adapter plate for the micro servo that I'm using. So I could still go back to a mini servo if this micro servo doesn't work, but I have no doubt that it will. Here's my nut plate. Everything's been sealed. That will go down in here on the inside of the transom for mounting up the outboard motor. And then here's my motor mount. I got that sealed and all fit to where it drops in, and I can mount the motor, and that's all sealed up. This is mostly for Dr. Jet, but also for anyone else that wants to make their outboard motor height adjustable. Those are 1/8 inch wide slots, so I drilled the ends of the slots first. So here's the measurements to the center of the drilled holes. It's 1/4 inch up from the tunnel plate, the bottom hole on the bottom slot, and then 1/4 inch up from there, drill the second hole. And for the top slot, the bottom hole is 15/16 of an inch up from the tunnel plate, and 1/4 inch up from there. And obviously the width matches the hole pattern on the outboard motor, and it's centered on the transom. Here are the dimensions for the slots for clearance on the pull cables. For anyone that wants to run their servo upright like I did, from the tunnel plate, the bottom hole is 13/16 up and 1/4 inch up from there to the next hole. This will give clearance on the pull cables when you move your outboard motor up and down, and they're 1 inch apart and centered to match up with my 1 inch servo arm. Those are also 1/8 inch wide slots, so I drilled 1/8 inch holes on each end first and cut out to the holes. And I'm not running any kind of a waterproof boot. I did the same thing on my G30 for clearance on the pull cables, and I don't have any issues with water intrusion. I waterproof all my electronics anyway, my receiver and my servo. Take them apart and put conformal coating on all the internal electronics. and the amount of water that would get in here is minimal anyway. This is also mostly for Dr. Jet. If you want to figure out these hole locations precisely yourself, in the lowest position, the bottom of the outboard bracket is a 1/16 of an inch up from the tunnel plate. I have one more thing to share with Dr. Jet before I finish up with sheeting these sponsons and sealing everything else up. And that's how this universal motor mount plate's working out. So here I have it screwed to the motor, and here's the plate that's glued into the hull. So I have 3 holes in this plate to clear the motor shaft and the heads of these screws, but I had to elongate all 3 of them by the thickness of this plate that creates a slot that captures the bottom of this plate. That way we can drop the motor in. So slip the motor shaft through, drop this all the way down to that bottom plate that's creating a slot, and then the elongated slots for the heads of the screws lets this go up against the plate that's glued in the hull, and then push that down into the slot, run your screws in. And we got clearance on the side of the motor to access those screws. And then to remove it, I just pick up on the motor shaft, pull it up out of the slot in the bottom that captures the plate, and it's that simple to remove the motor. Building sponsons is always a lot of work. You figure the building of the frame, putting in the flotation, all the sheeting, sealing everything inside and out. Very labor intensive. But I'm of this mind that sponsons give a boat character. It's where the boat gets its looks from, and the performance. I am really impressed that Dr. Jet got this much character, looks, and I think also performance with such a simple design. I have everything sealed up now. It's still wet. I just finished putting a coat of sealer on the outside of all the sheeting. Don't forget to seal the inside before you bond on the sheeting. But just finished it up. There it is. Coming into focus, the TunnelJet.